ये मेरा द्वितीय अवसर है जब मैं मिस्टर प्रकाश राव को सुन पाऊंगा संसद सभागार में ही। उनका ब्रीफ प्रोफाइल है। Mr. Prakash Rao PJVKS retired as an outstanding scientist in Indian Space Research Organization, ISRO. He was serving as Director, Space Infrastructure Program at ISRO headquarters, Bengaluru. Just before retiring, reporting to the chairman of ISRO, he briefly held the additional charge of Director DSRQ, Directorate of Safety, Reliability and Quality at ISRO headquarters. Prior to this, he has served as Program Director, LEO and Planetary Platforms and Deputy Director, Spacecraft Reliability and Quality Area at UR Rao Satellite Center. Earlier to this, Mr. Prakash Rao served as Project Director, GSAT-9, South Asian Satellite, GSAT-17 and GSAT-18 Communications Satellite, and also Project Director for GSAT-6 spacecraft, which had flown the 6-meter unfurlable antenna, the largest onboard antenna built by ISRO. He has also served as Associate Project Director of Meteorological Satellite INSAT 3D and Group Director, Systems Reliability Group at ISAC. After completion of his MTech in Electronic Instrumentation from REC Warangal, he has joined ISRO Satellite Center during May 1985 in Quality Assurance Division. And in his 37 years of experience at ISRO, Mr. Prakash Rao has worked in diverse areas of satellite systems such as test and evaluation of sensors, control systems, digital systems, and power systems. He has also contributed as project manager, deputy project director, product assurance for INSAT 2E, TES, and IRS P5 spacecraft, and head Parts, Materials and Process Division at ISAC. He was on deputation for 2 years to Boeing Satellite Systems USA, formerly known as Hughes Satellite Systems, as technical consultant for Malaysian Communication Satellite Operating Agency, MESAT. In realization of MESAT-3 spacecraft as product assurance manager of W2M spacecraft, ISRO's first commercial spacecraft supplied to European operator Eutelsat in collaboration with Messrs. EADS, Austrian France, he handled the customer interface on PA aspects. He has participated in several launch campaigns of ISRO satellites for launch by Arianespace from French Guyana in various functional roles. Mr. Prakash Rao is the chairman of PMC, Project Monitoring Committee, for 75 student satellites mission announced by Prime Minister as part of Azadi Ka Amrit Mahotsav, has been realized by Indian Technology Congress Association. He has conducted product assurance workshop at RCI DRDO and was a member of faculty at several ISRO internal training programs, ECIL, courses on satellite engineering at IISc, etc. He also served as the chairman of organizing committee for Unnati program, which is a commitment given by India to United Nations about training of personnel from developing countries on nanosatellites. He was member of Space Generation Task Group and ISRO Strategy Group formed to brainstorm on the potential future programs of ISRO. Mr. Prakash Rao also served as member of Committee for Promotion of Space Satellites formed by ISRO as an interim arrangement before formal in-space mechanism was put in place. Mr. Prakash Rao is awarded ISRO Merit Award in recognition of his meritorious contribution to Indian Space Program and is a National Governing Council member of ISSE, Indian Society for Systems Engineering. He has served as Executive Chairman of Astronomical Society of India for 2 terms. Considering his significant contribution, he is admitted as a Fellow of the Astronomical Society of India. And apart from Mr. Prakash Rao, we have with us today Dr. Dwari and our Dr. Mundra. Of course, there need no introduction here to the members. Hence, after Mr. Prakasha will take the stage and he will address you.
okay, now I'll just say a couple of.
Dr. Duwari.
I'll stay. So we want to say something.
Ankit Singh. Just.
ঠিক টাইমে চশমা খুলে গেছে ঠিক আছে ওকে I'll just manage it this way. ঠিক আছে A very good morning to everybody present here. I think it's a really a very happy occasion for Bharatiya Sanskriti Sanshad, of which I'm an honorary member, and also personally for me to be in the company of a giant. He doesn't look like a giant, but you know, any big organization, any big institution, any big vision, it always relies on standing on the shoulders of giants. And for 37 years, his work, his expertise, his capabilities, his vision has created a platform along with so many other very famous scientists to create ISRO, to make it develop, to bring it to a stage where India is now considered one of the top 4 to 5 countries in the world in space science. So it is really a matter of honor and privilege for all of us here today to be in his company, and later on, maybe within another couple of minutes, to hear from him about the story of success. ISRO, to me, from my childhood days, is a place where, or is an organization where magics happen, at least for a child. Why magic? Because sending a rocket to a child of, say, 5-6 years is like a magic. But now, slowly, as I came to know little about the workings of ISRO, how it happened, how it progressed, I realized that what a tremendous amount of effort in manpower resources, human resources, in terms of intellect, in terms of money, in terms of goodwill of policy makers and decision makers, everything has come together. And today, the whole country is talking about Chandrayaan 3, Chandrayaan 2, Gaganyaan, this and that. But we are forgetting that apart from these spacecrafts which catches the imagination of common people, ISRO has laid a strong foundation for the whole development of India in terms of land uses, land resources, water resources, telecommunication, atmosphere, climate, communication among other people, communicating with other countries, as well as space science. So it is one of the only agencies probably in India, apart from the political system, which touches every human being, every Indian, knowingly or unknowingly. So that's an amazing fact. But just to give you an idea, today is actually a little special day. Yesterday, it was the birthday of Vikram Sarabhai, right? Who started ISRO along with Homi J. Bhabha. And 2 days later, on our Independence Day, ISRO will have its birthday because it was in 15th August 1969, ISRO was formally agreed upon and launched by the government of India. Later on, it came under the DOS, Department of Space, and so on and so forth. Think about an organization which happened in a country which earned its independence only 76 years back. 419 satellites, all of them foreign satellites, ISRO has launched successfully. Total number of spacecraft missions, 116. Launch missions, 86. Student satellite, 13. And re-entry, going up and again coming down, re-entry missions, 2. So that tells you, you know, in a very lighter vein, whenever we talk to a kid and talk about space science and say, NASA, amazing organization, fantastic. But I'll give you one of my experience. Couple of years back, I'm an associate of NASA, so I was listening to the NASA director's Christmas lecture. They have this tradition of giving a Christmas lecture, which happens not on Christmas, but around 10th of December after that vacation starts. Sacker, he gave us statistics that in the last 60 years of NASA, among all the launches that has taken place, NASA has been successful 72% times. And at the same vein, he said, in the last 45 years of ISRO, among all the satellites and launching that ISRO has done, the success rate is 91%. This thing we do not talk about, right? We are talking about Chandrayaan, or prior to that Mangalyaan, where the budget for the interstellar Hollywood film was 4,800 crore rupees. And our Mangalyaan was sent at a budget of 484 crore rupees. These are the aspects which will light up the imagination of the younger generation. Not only the science, the equation, the calculation, not only that. The feeling of oneness, the feeling of Indianness should come to the younger generation through the achievements of present India. History is important, but the present is more important. So that is my feeling, that organizations like Bharatiya Shastriti Sangshad, to some extent Vidya Mandir, it is not only showing us our heritage, it is not only showing us where should our moral value sense, our sense of propriety, our sense of analyticity should come from, but it should also give us hint where it should move and in how the pathway, how it should move. And in this particular respect, today's program is very, very important to me at least. You have heard his resume. It's a very impressive one. I feel just like a dwarf in front of him, listening to him. And I will tell you, though his demeanor is very gentle, very polite, but in his profession, he rode like a lion. I'm not just saying it, I've heard it. Because the decisions that he has taken, the leadership that he has given to different committees, different activities, different projects, was absolutely professional. So this is also a part of our learning. That hardcore professionalism or a very top level academician should not always look a very stoic, almost rude, almost don't care attitude to everybody around, because they are lesser mortals. A lot of scientists do that. That should not be. He's a part of each one of us. At the same time, he's much above all of us in some respect. So these are the human angles, because he'll be talking about technical things, professional things. I'm not going into that. But these are the human angles. And especially this time is very interesting. By 2018 standard, just imagine, a project which is 80,000 crore rupee project, one project, was launched in 2021. And 25th December, called James Webb Space Telescope. And I was reading some articles about it. In 1 year of operation, it has turned out data which is changing totally our concept of the universe, which happened in the last 150 years. Right? When I was talking to Dr. Mundra, that earlier we used to say that universe is 13.797 billion years old. Now, in the last 1 month, papers are coming out which is saying universe is 26.7 billion years old. Everything is going out of the window, including the Big Bang hypothesis where the questions are being raised. So this is an exciting time. Every 50 years, 100 years, human race come face to face with a totally new realization of reality. It has happened. Earlier it used to happen through social reformers. Now it is happening to technology and scientific reformers. Things have changed. And Professor Rao is a part of that group of people who is changing our concepts, perception, outlook, and vision for our future, for our science, for our technology. So I will be happy to not only to welcome him, but we will all be a student for coming 1 hour or so, and he will be teaching us how to look towards life in an analytic, scientific, productive, and visionary way. Thank you very much. We shall go down a little bit because we have to use this.
We will go there.
Yeah, and this table or chairs, if somebody can please help. Catch it.
नमस्कार। भारतीय संस्कृति संसद और भारतीय विद्या मंदिर के सब सदस्यों को मेरा हृदयपूर्वक प्रणाम। मेरा पावर पॉइंट ओपन करने के पहले ही मैं कुछ बोलना चाहता हूँ। मेरा दिल इतना खुश हो गया बिकॉज फॉर सच ए प्रोग्राम ऑफ साइंटिफिक इंटरेस्ट, मैं तो इतना एज्ड पर्सन्स को देख रहा हूँ, उन्हें देखकर मैडम आप सबको मेरा प्रणाम सर। बिकॉज अभी भी आपका जो इंटरेस्ट है, द इंटरेस्ट टू लर्न, सो वी आर नेवर द इंटरेस्ट गोइंग टू लर्न इज सबसाइड, और सीइंग सच एल्डरली पीपल come all the way on a Sunday instead of just relaxing, वो घर से इतना दूर से आके इतना उत्सुकता से 1-2 घंटा बैठना। आजकल तो बच्चे को 13 मिनट्स से ज़्यादा लेक्चर है तो वो सुनते ही नहीं, वो बोलते हैं वो टेड एंड ऑल लाइक दैट। बट सीइंग सच एल्डरली पीपल, आई रियली गेट एक्चुअली, इफ एट ऑल आई वाज नर्सिंग द थॉट्स ऑफ रिलैक्सिंग, आई थिंक सीइंग यू ऑल ऑफ यू मैडम्स एंड सर्स, मुझे ऐसा लगता है कि मुझे कभी भी रिटायर नहीं होना चाहिए मेंटल सी। सो यू आर द इंस्पिरेशन फॉर अस, सीइंग पीपल लाइक दिस, एंड डॉक्टर मुंड्रा जी who is making this possible with his visionary zeal, enthusiasm, and in-depth, not just gain and bandwidth they say, so not just the bandwidth, but bandwidth with extraordinarily high gain. In so many fields, he is able to generate interest, and having yourself interest is one part, but spreading it in the society and making people more and more, and to bring a gathering of this together. Of course, West Bengal is a known state for its intellectual capital of India, I can say, I think. Okay, so it may be little easier here, but still to sustain this interest and to support it both emotionally and financially, all these things, I think the Samsad is doing a great job. So I would like to, at the outset, thank all the elderly members especially, and the younger members from ISRO and all who have come here. Both of you inspire me. बच्चों से भी सीखेंगे और बड़ों से भी सीखेंगे, ठीक है। सो विद दैट स्मॉल इंट्रोडक्शन आई वुड लाइक टू एंड पावर पॉइंट ओपन करना है बिकॉज some other yeah. So my presentation is going to be, because mostly I will be addressing lot of students in the schools also. So from very fundamentals I will start. Straight away going to Chandrayaan is not correct. So पहले क्यों space किया चाहिए? What is it that we get the advantage by going into space? Yes. ठीक है सर, I think इसको क्लोज करना है।
This is the one. Myself and my son.
Yeah. Yes, slide show.
I will adjust.
Yeah, because this laptop looks little unfamiliar. Yeah, okay.
It should come here.
Yeah, that they have to select. I think you have to select the feed here.
জুমে হোক না হোক আগে তো ওনাকে দেখাতে হবে, দেন ইটস জুম, সেটাকে করুন আগে।
आगे आगे only the intensity may have to slightly increase or ठीक है. So both me and my son, we really feel honored to be in this culturally, literally, and by all means rich state of West Bengal, which is having such a good heritage. And yesterday day before, we roamed around city of Kolkata. Sandeep has taken us around, which is having a really, I think, what it means to be in West Bengal, the cultural and literally capital of India, the land of Ramakrishna Paramahamsa and Swami Vivekananda, Gurudev Rabindranath Tagore ji, Netaji Subhash Chandra Bose, and as we come, Satyajit Ray, in science, Jagdish Chandra Bose, very, very reputed institutes like ISI, IIM, ISRO. Then, of course, coming to the youth part, Mohan Bagan, East Bengal, we know how Calcuttan blood will rush through when they mention these clubs, okay, and there may be there may be fans of both the clubs here, okay, so that is the one thing. And Saurabh, who infused aggression into the Indian cricket. Otherwise, we were like our normal old thing, but he brought aggression into Indian cricket. So, and for many, my mother tongue is Telugu. Many of the famous Telugu movies and very musical hits like Devadas and all, the inspiration was from Bengali films and okay, like that. And the land which gave Vande Mataram and Jana Mana, which is a very rare, I think, honor for one state to give both two anthems in which we fought for our independence and subsequently our national anthem, and to be in the presence of so many eminent thinkers, artists, and I think you are having full spectrum of people here, and some of the budding scientists from ISRO, we have just seen, I heard the areas in which they are working, they are all Greek and Latin to me, okay, maybe Dr. Duwari will be appreciating the studies they are doing, because we are more on the technology side, science side, anyway, sir is there. Okay, and I would like to thank specifically Rajgopal Surekha ji, Shankar Somani ji, Suprakash ji, Sandeep bhai, and Ashok, who has taken us around, the driver. So I like thank for making our stay very pleasant here. And of course, the first as well as the last, we will never forget our gratitude to and pranams to the visionary leadership of Dr. Bitaldas Goenka ji, Mundra ji. So I will be covering, as I said, before moving to Chandrayaan, that is the climax, okay. Initially, we may tell how ISRO has risen, very, very shortly. I will not be spending too much of time, but just to give a glimpse and why. So this is what I am going to tell, Indian Space Odyssey, from sounding rockets to landing on the moon. So we presume that it is as good as landed. This time it should land, of course. So even before that, I would like to pay homage to the contributors to Indian astronomy and space technology, both of them, because space technology enables the observations in the astronomy much better. Earlier also, even when there was no space technology, our astronomers like Aryabhatta, Varahamihara, Brahmagupta, Bhaskaracharya, much before such a time of 500 to 1200 AD, those times itself they have made some very, very illuminating discoveries without such a powerful aiding instruments, and of course the modern fathers of Indian space science. So why space? First of all, okay, why at all you have to go to space? This is one question which has to be understood clearly. So whenever we go to in space means a satellite going to a orbit, the main advantage the main thing you are doing by going to that is reaching a higher height. Why you have to observe or communicate or do anything from a height? So what is the advantage of time? Even if you see before space itself, if you see any big buildings or forts and all, like people from Rajasthan also will be here definitely. So all the forts and all will have some watchtowers. So you go to a height, or especially ports and all, there will be a lighthouse. Why you are going at the top and watching? And even in film Bahubali, one carpet will be there which will be going and burning carpet which goes and falls on the enemy's soldiers when they have to do. So all these are the things where the height is offering you an advantage. Here you are getting, as you go higher and higher, we are getting a larger and larger coverage. So that is the major advantage of going to the height. And another is it's obstacle free. Nowadays marriage receptions, everywhere you go, the drone will be making a lot of noise because you want to, because so many people are sitting, you want to clear the obstacles and take the photograph. That's what the drones are doing. In the earlier, photographer used to come and push us away. Now drone will take care without pushing you. It is taking care. So that is another way. You assume spacecraft as a much higher level of drone. Okay. Then unaffected by natural disasters, especially when you want to, some calamities are happening, some earthquake, you want to assess the damage. To physically go there and do is just not possible because all the infrastructure will be cut off. So that is where the space offers a very good advantage and not restricted by borders. So if you want to know what is happening all over the world, you can do it by going on a spacecraft if you are having observation. Otherwise you need so many clearances, and that is another major thing. And privacy and security, okay, that is another aspect. And because anything you put on a ground, it is easy to destroy that asset. If you are having an asset which is doing all these strategic applications, see, destroying a space asset also is possible, but it cannot be done by a person with an AK-47 or few hand grenades. They cannot attack the resource which is in space. Okay, that needs a very high level of technology, very high level of infrastructure to attack a. And when they attack, they know that we also, like Mission Shakti, we have demonstrated. So anybody now would like to, if they want to touch Indian space asset, they will think twice because their asset, if you hit one asset, their two assets may go. So the deterrence is there. So that is another advantage of this. And repeativity. If you want to image some area again and again and again, how do you do it? If you are doing helicopter sortie, or even now I am going to height also, aerial survey or anything you are doing, you have to go after fuel is getting over, again you have to come back. But in the spacecraft, that kind of disadvantages are not there. And flexibility, you can view here, there, you turn the spacecraft attention to another area. And expandability, just add one more spacecraft, your scope is, or you want to, now you are getting every 12 hours one image, you want every 6 hours one image, launch another spacecraft at a different phase, then you will be able to. So all these advantages are there with respect to the space. And there are disadvantages, of course. As we go higher and higher, you are sitting like a, even big building will look like an ant. Okay, so you need technology to make it look like what it is. So that is where the instruments have to be developed. And loss of signal in communications, as you are inverse square law, okay, for those who are familiar, as you are going farther and farther, the signal level is going to drop so much and like that. And unwanted signal along with wanted, because you are seeing more and more, along with what you want to observe, there is so much what you don't want also. So how do you separate signal from the noise? So that there again lot of technologies are involved. So that is what is involved in making a space systems. And environmental effects. A satellite in orbit, I will be talking about it, will face so many environments. So all of those it has to withstand and be able to do its assigned function. Then the cost, of course, when you are doing anything higher thing, but it may be costlier. One spacecraft may cost few thousands of crores, but same job it has to be done by terrestrial means. One thing, so many times it is impossible, like I told, like you want to know what is happening in Pakistan, you cannot do it by terrestrial means unless you do it a very spy way. Now actually spies and all will lose their thing will be very much reduced because you have ice in the sky. So that is the one advantage. Apart from that, even if you are able to reach also, the cost when you really multiply over the total thing that you have to do, space assets are much much efficient. So now different applications of space, I will not be deliberating very widely, but space for communications. Now earlier we used to have cable TV and all, now everywhere DTH has come, direct to home. So that your dish you point towards the satellite, then we are able to get signals. So that is the wide coverage. Then few slowly, especially some inaccessible areas, okay, like Kargil or such places where soldiers are working, they are not able to communicate with their base stations, or they are not able to communicate because even terrestrial infrastructure will not be there, or to their own beloved families. So if you are having a satellite phone, directly, because satellite is up there, it doesn't matter if they have a good receiver, okay, of reasonable size, they will be able to mobile communications, apart from regular or whatever TV, broadcasting, telephone, all those things are there. Then there are of course some challenges, I will not go too much into that. And space for remote sensing, that was for communication. Remote sensing is sensing from a distance. बहुत दूर से आपको देखना पड़ेगा कि यहाँ क्या चल रहा है. It could be, one is for agricultural, forestry, biodiversity if you want to see, or some forest fire is happening somewhere, especially US and all, it is very common for forest fires. Here we are not very familiar, but in countries like US and all where there is a large forest coverage, forest fires are very common in the summer. So all those damages, how much of jungle is damaged, or some flood has happened and later you want to see what damage happened. This is one kind of thing. Otherwise, wheat crop is grown. What is the yield or what is the estimate? Okay. So Frederick Forsyth, again, some novel was there where America will be spying on how the wheat is getting grown in Russia, because their yield or something, they want to plan according to that. In that they find that the Russian wheat crop is affected by some particular weed. Okay. Subsequently what they do is, now they know that soon Russia is going to have shortage of wheat. Immediately they will increase their production of wheat, keep it stock, and of course sell it. It is business wise also you can use. Or like that, there are so many applications in remote sensing. And our own minerals, mapping, all those applications are possible. Again, limitations I will not go. Here the important term is the resolution. And strategic applications, of course. Border troop movements are happening, or tanks have come and stood. What is the progress every day, inch by inch, if they are moving? So if you are having a very good resolution, now we can see the runway markings in spacecraft imagery. You can see the runway markings we can read from spacecraft imagery. From a satellite which is around a 900 kilometers height, we are able to see runway markings. Okay, so that is the another thing. But here the main important aspect is the reliability of spacecraft, because spacecrafts have to work for some 15 years like that. Some communication satellites have to work for 15 years and all that I will come. And navigation. Today nobody, Calcutta I have seen, somehow Google Maps and all are not so highly used. Still people are having this one, but elsewhere if we go, we can navigate. Earlier we used to stop car or motorbike somewhere, either kaisa jana udhar, nothing like that, everywhere navigation. Now the navigation is possible only because of the satellites, GPS satellites. Then meteorology, in TV every day we see weather, every half an hour the whole globe we are able to see. It is getting mapped and what is happening, and especially Hudhud and all that kind of. Earlier in my state Andhra, Divisima and all, when some floods have come, thousands or hundreds of people used to die. Now have you any time heard that more than 10 people died in any, and many of even the 10 or 6 who would have died also, they have refused to vacate their own place or some such things. Otherwise, very advanced warning, and every minute by minute movement of the cyclonic patterns, all these things are available. Okay, that is because of the satellites. From geosynchronous orbit, 36,000 kilometers height, we are having VHRR instruments on our communication satellites. So where you are able to monitor the progress of these things. So that is another advantage. And space science, of course. That is where, why you have to observe things on ground. We have so many telescopes and research institutes like Birla Planetary Research Institutes and all, they are there. So many ground telescopes are there, so you can. But the problem is, it is obscured by the atmosphere. So once you go into space, the problem of these atmospheric effects are not there. You will be having a disturbance-free viewing. So that is another advantage. And planetary exploration, of course, is the theme of today's thing. And okay, this is just to show the spread of space centers and all in India. I will not go into detail, but just suffice to say that it is spread all over India. Okay, we are having centers. Just now sir was mentioning he has gone to NESAC, Guwahati, like that. So So there is the space activities are spread all over India. There are centers, and for the youngsters who are interested, if they want to join also, there are plenty of options without moving too much away from your own near and dear ones. Okay. And when we talk about space segment, satellite is the final thing, but it consists of three segments basically. One is the transport. Of course, that is the most impressive part of the space launch. Satellite, once it goes up, nobody will see. But the rocket, okay, or launch vehicle, what we call, that is the transportation, taking the satellites from here to ground to the required height. And the space segment, that is the real satellite and the payload, and ground segment. To control both launch vehicles as well as spacecrafts, we need some stations, and the data that is coming from the spacecrafts has to be collected and further relayed and all. So for that, there is a ground segment. So now I'll tell what is special about space systems. Why when you tell, they will tell it's not rocket science, like that they'll tell anything if it comes, they'll tell, oh, that is not rocket. Why rocket science is so difficult? Means first thing and most important thing is the unattended operation. एक बार लॉन्च किया तो 15 साल उसको कुछ नहीं कर सकते हो, 15 साल तक काम करना है वो सैटेलाइट की. So unattended operation, बिना कोई assistance. Our car, if it gets, we can go to a workshop, you can get it fueled again. Okay, nowadays refueling and all we are thinking of, but in a very low Earth orbit only, like that. So that is one most important characteristic which distinguishes the spacecraft from rest of the systems or rest of the terrestrial systems. Then multidisciplinary product. Any branch of engineering, you collect all engineering college names, take all the branches which are there in each of the college, and make a superset of that. Every branch will have its application in the space technology, and not just engineering. It would be science anyway is there. Then even medicine you take. Now with astronauts and all going into the space and becoming so common, and we ourselves launching Gaganyaan, space medicine is going to be another very important subject. So every subject, management anyway, because to manage projects of this magnitude, so you need project management techniques, all those things are there. Then hostile work environment of space, this I will talk about, and low volume production. अगर आपको एक mobile, if you have to make it reliable, it is easier. Our cars, Toyota, they told zero defect policy, Six Sigma and all that they will tell. So how you are able to make it? That is because numbers are so high. When you are producing in millions, to establish a system, follow that, some quality control methodology, all that is easy. But spacecraft takes, like Chandrayaan you take, original one, may take 10 years to build. Or James Webb Space Telescope sir was mentioning, it took total from concept to the completion 40 years to build. Over 40 years, how many project directors would have changed? How many places, different places? How do you keep the culture of quality alive in the team? And how the data communication from one team to the next team, all these things are very, very unique. And volume, mass and power constraints. Even like car also, now you want to improve something, optimize the fuel efficiency and all, it's something. But here the problem is launch vehicle is fixed, it can take only this much weight, it can only take this much volume and this much mass, power that you can generate is limited. So with all these constraints it has to work, and of course high cost. So space environment. So here I will just give one example why environment is important. Okay, my sisters, they have moved from, say, just I am giving example only, Hyderabad to Kolkata. So today she has sent her son to some school, very prestigious school in Kolkata. So there by afternoon the school principal has called my sister and told, your son is very naughty, he is making a lot of galata and the children around, he is disturbing them also. Then my sister told, no, he is very nice boy. Actually, previously we were in Hyderabad. From Hyderabad we have moved to Calcutta now only, or reverse I will do. Okay, Calcutta to Hyderabad. Okay. So the children here in Hyderabad are very, very naughty. So maybe in the, actually our neighbors. So the neighbors, actually there the school he was very much appreciated. Here our neighboring children are all very, very naughty. So that's why maybe joining them he has become like that, he told. Anyway, don't worry, his father will come, I'll tell him and he will set him right. Okay, evening he has come back from school. Now he has gone to play along with the children around our house. Okay, they went to playground. After half an hour they have come and the door, knock, knock. Then my wife opened the door. Then they came, what, your son is very naughty in the playground, he is pulling the leg of that boy, this boy, he is making lot of galata. Then she told, no, he is very good boy. Actually, all children in his earlier neighborhood, they used to like very much in Kolkata. Now only we have come to Hyderabad. Today he has gone to a new school. Okay, maybe the school children there and all are very, very naughty. So along with them, he has got spoiled himself. But don't worry, we will take care. Like that she has told. So this is, I am just telling how the environment surrounding you can influence the behavior of a particular person or a product or a system. That's why we always tell, Acha mahol bana ke rakho around you, so that we also will be in a good environment. So here the space, when we talk about, there are so many main important launch. First, during launch itself, launch vibrations will be there, launch acoustics. Then there are something called Van Allen belts, where there is a radiation trapped. Apart from them, temperature. The solar panels, whatever we see in the spacecraft, they will be experiences temperatures from -100 to +100 degrees centigrade. And the vacuum, we all know space shuttle, how they float. But these designs which we do for Earth system cannot hold in vacuum. So our 0G is another important. Gravity is not there. So our very less microgravity environment. So the designs and all have to be made for that. Weightlessness, deep vacuum. Vacuum itself has some effects on materials. So we have to account for all that and design the spacecraft and test for it before going. So you should have huge facilities to test for those environments. These facilities and all, sometimes they cost tens of thousands of crores. Okay. So this is all what makes a spacecraft is very interesting and challenging and difficult also. So this is another important aspect. When we talk about satellites, we should talk about orbits. For different applications, orbit is basically dictated by two things. One is the distance from the Earth's surface to the height at which the spacecraft is going around the Earth or Moon or whichever object it is going to circle around. So that is the orbital height and inclination. Inclination is with respect to the equatorial plane, what is the angle that the orbital does. So for spacecraft, communication spacecrafts, which have to constantly, otherwise what happens if it is at a low height, it will not be seeing same place. As it is going, every moment the place will be shifting. Okay. So in geosynchronous orbit, the rotation of Earth and the satellite's rotation rate will be same. So we will be able to observe the same space on the ground. So that is helpful communication, and different orbits are there. So that's why it is like a real estate only, where everybody wants to live in this place only, Chorangelian only, because a lot of business interests are here. Like that, everybody wants to put their satellite in geosynchronous orbit, because it is very precisely only that height you have to be there. So all over this, but different phases, different longitudes you can keep. So that is one thing. So there is a lot of crowding, and a lot of internationally there will be a lot of. So this is another important application of satellites, which is Gagan, which India has taken very much interest, and where the GPS is aided by 3 satellites in geosynchronous orbit, which helps the aircraft to land under any circumstances with a very high precision. This is approved by now Airports Authority of India also. This is okay. I just wanted to tell how even a smallest detail can result, if you miss, can result in disaster. What you are seeing here is a metro, okay, in that Antonov is the aircraft. So all our spacecrafts are transported if you are going to elsewhere, say French Guiana or somewhere for launch. So there they are transported. Right side what you are seeing is the, okay, one of the spacecraft container, and here this is our own Indian satellite container, you can see here. It is being unloaded, and that is inside of the aircraft. Here what I am showing you is, it's not real container, but these are shipping containers. What happened was, we arrived at Kourou, we unported our satellite, we have unloaded, and we started our operations. 3 days later, a Japanese spacecraft was supposed to come. So that has come, and they brought and opened their container in the clean room. They had some tarpaulin or something that they removed. When they removed, equivalent to this, their container picture I cannot put, so their shape has become like a sand hourglass. After coming from Japan to French Guiana, When they opened, it was in this shape. Why it happened? Because aircraft normally when we are going, it is all pressurized, cabin pressure, and whenever cabin pressure drops also, you know, oxygen mask will come, all those things. But for cargo aircraft, where it has to just take luggage, the pressurization is limited only to the cabin where the pilots will be there and the loading, unloading crew will be there. To them alone it is done. Rest of the thing is not pressurized, so it will be changing with the, and as you are going higher and higher, pressure is coming down. Then what happens when the pressure difference is there between outside and inside? The shape will be, because it is pressed, so it happened. Then it is common, everywhere it should happen. For that what we have is something called breather valves. So on the containers we will put valves which will be breathing in and out the air to equalize the pressure, so that such a disaster will not happen. But here what happened is that Japanese, maybe before loading someone has put a tarpaulin because they just wanted to protect, or rain something was there. Before loading into the aircraft they should have removed the tarpaulin. These breather valves are there. आपने सब कुछ डाला है, but बुरखा डाल दिया तो क्या होगा? All the things are there to breathe, but finally you put something and tighten. So it was not able to, the breather valves were not able to function. So here the devil is in the detail. Pay attention to detail, especially the programs which are not attendable, which cannot be serviced later. These things, if we don't pay attention, how they can lead to disasters. This is just an example I wanted to tell. So very, very minutest detail. This nobody will think that removal of, non-removal of tarpaulin can cause such a, and later they have anyway spoiled their aircraft, their spacecraft. They had to come after 2 years after repairs and all. Our launch also got postponed because we have to go along with them. 3 months it was postponed till we found a suitable passenger. So another important aspect of review is in ISRO is reviews. Any ISRO chairman you ask what is the reason behind success of ISRO, one of the things they mention is about the reviews. Because whatever we do, we never limit it to ourselves. We always subject it to review by eminent people in the field and within the organization also. Just the importance of review, I always tell to youngsters especially, is if somebody is reviewing your design or your product. So what will happen here is, actually I attended one project management course. There the foreign professor came, he showed a video where the record in the high jump was not beaten for quite number of years. Then came one person, normally they used to do high jump like this only. But this person came and now all the people take their head first and then they take like this and jump. So he tells the tagline, if you want to reach higher heights, use your head, not your foot. Okay, that's what he says. So in a review, it's not just one head. There are 10 people from different fields. It could be applications, it could be mission, engineering, systems, okay, and environmental specialists. Like that, various people are reviewing our design. So that will definitely help to sharpen our, so even for you, if you have to, suppose thesis you have to present tomorrow, some other forum when you are presenting your thesis, you will be, if you have to do yourself it is different, but when somebody else is there to question, you will read same thing 4 times. Even this PowerPoint today also 9 o'clock once again I have seen, because some 10 people are going to see, so it has to be perfect. So that is where the review helps, and this is one of the important things. And one general question, now after this I will move to Chandrayaan, okay. So generally wherever I go, I will face one question, what is the success, formula or reason behind the success of ISRO in a government organization. Otherwise there are so many private enterprises who are doing their thing, but in a government setup, how such a complex job is being accomplished so admirably, what is the reason? So first thing I would like to tell even before going through is, it is due to the teamwork. Sir was telling something like a dwarf or this, nothing like that, I am a dwarf only. It is only because 10 such dwarfs have worked together like ants, you know, each ant nothing it can do. But when thousands of ants come together, they can, even a mountain it can, or even a big tree it can smash. So it is the team spirit that is the first reason actually, though here I would have written somewhere. But it is a team that is going to make the work. Whatever we may, actually in India we have a bad habit of making one hero out of everything. Without hero we cannot, but I think that hero worship within ISRO is not there. We all know that for anything to succeed, for a mission like Chandrayaan to succeed, the contribution of a helper who carries, suppose, some component from here to there is as important as that of ISRO chairman. Okay, so it is the teamwork. Then we can do its spirit. You give any job, however tough it is, immediately he will not tell that it is not possible. Okay, okay sir, we'll do it like that. Celebrate each other's success. This is another important thing. And not deterred by setbacks, of course. मुसीबतों को देखकर मुस्कुराना और मृत्यु को देखकर उछलना यवन का शील है, like that. That is the spirit of not only ISRO, all successful space organizations. They are not worried about the setbacks. And openness, and there are so many, and no hierarchy. That is another very, very important thing. Okay, now before I move to Chandrayaan, I think there are a lot of reforms that are happening in the Indian space system. So far, space in India means only one name, ISRO, Department of Space. Now the government wants to expand. The basic objective is to, because here some entrepreneurs also may be there, that's why I am telling this. So the basic thing is, out of $350 billion or whatever economy review is, the market is there in the world, Indian share right now is 2%. So the government wants to enhance it significantly. That cannot be done just by being in government sector. For that, you have to move to private sector. With that objective, different entities are created. ISRO is already there. NCIL, New Space India Limited is there, who will be doing to act as an exclusive public sector aggregator. And in space, this is the most major thing recently they have done, Indian National Space Promotion Authorization Center. Promotion and authorization, both of them are with them. So people in private, the idea is to enable them and open up ISRO facilities, because ISRO facilities are built at public cost, at public funds. So anybody in a private sector wants to use a facility of ISRO, they can use it by paying some nominal. Otherwise, if they have to set up the facility themselves, nobody will come because the risk is so high, and you will not be having. Now the total thing will be in lakhs of crores. So who will come with taking that risk? So all this is open to public. So this is just, I thought I will just tell about the system. Now we'll move to space science and planetary exploration. As big achievement was for the many firsts were there, and it was first successful Mars mission in the world, where in the very first attempt we succeeded. So much so, I think the greatest thing is, among the recognitions, if you see, China has referred Mars orbiter mission as the pride of Asia. That is what China has referred in one of its articles from the government side. So that is the kind of impact it has made all over, and of course there are so many other technical things. Now this particularly Dr. Munraji asked me to cover about James Webb Space Telescope also. I will be telling more on the okay. So it took 25 years to build from initial design, but discussion started 40 years back itself before that launch. So that is the kind of planning and execution time they have taken, and it is the costliest space, lakh crores. Whatever rockets we see will be maximum 1,000-2,000 crores. Okay, but the James Webb Space Telescope, and next costlier mission will be India and America are doing together one NISAR mission. NISAR, NASA ISRO Synthetic Aperture Radar. So that will be costing 10,000 crore rupees, because it has to work for so many years without being attended with very sophisticated instruments. And several thousands of scientists, engineers and technicians spanning 15 countries have contributed to the build, test and integration of the web. That is where this up to 135 crore years back, whatever that is seeing today may not be there actually, because light takes, even light is the fastest medium of transportation, but even that takes, because the galaxy Anant, space is Anant, because this is Anant, some star which was born 135 crore years back, today we are able to get a signature of that. That star may not be there today, may be there, may not be there, okay. But we are able to trace that signal and trying to reconstruct what happened in the past, and to study galaxy formations, star formations, planet formations, all these things it does. there are so many instruments that is called near infrared 0.6 micron to 5 micron and middle infrared. This was Hubble was doing up to 2.4 microns only, whereas James Webb telescope can go up to 5 micron to 27 micron. That is the one which gives it the edge to go to 135 crore year back signal and watch, and even more, because now the discoveries are coming that it is much more than that from the Big Bang. FGS, and these are all the instruments. And it's a 350 kg technical challenges. If you take, the structure is 350 kg, it has to support a telescope which is weighing 6,200 kg. So in space, and pointing accuracy of 1 arc second. 1 arc second is 1 degree, one circle is 360 degree, divided by 361 degree, divided by 3600 will become, so that is the type of, so from hundreds of kilometers if you see, on ground it will come to some few millimeters or meters like that. So that is the type of sharpness or that much pointedly the instrument has to see. So that is where the control systems that which have to come. So that is the challenge there. And it orbits around sun at, there are something called Lagrangian points. So at L2 it will see, the advantage is while looking at sun, it can maintain the communications with the earth. Otherwise, due to orbital geometry, if you put somewhere else, then the communication to sun as well as earth, okay, sun or star or whatever here. So like our Aditya is sun, okay, so like that, but you are able to constantly communicate with sun. And the primary mirror will be there. It is a 6.5 meter dia, and it has to unfold in the, because that's such a big thing we cannot put in launch vehicle. So it has to unfold. There are so many small segments, it will be there and unfold. But that alignment of mirrors has to be to the level of something like 10 nanometer accuracy. So this, if you want to scale up, total India you take, you assume that total India is the size of the mirror, if you assume, because nanometers we have to go scaling up. This is just roughly I am telling, because NASA has told in terms of Texas state and United States of America. Here in this some West Bengal as one mirror if you take, like that 18 mirrors or so are there. Each mirror has to be adjusted to the accuracy of 1 mm or 2 millimeters in such a huge thing. So that is the technological challenge here. And of course sun will be there and all, so that radiation should not come. You have to separate all the noise, so that sun shields and all, these are all okay. And Ariane rocket has launched it on Christmas Day. Normally in Europe you cannot get any work done on Christmas Day, complete vacation. But those people were able to do it on Christmas Day, okay, because of the importance of it to the humanity. And soon after launch it was hit by a meteor. So that was also, because it has got provisions to take care of minor hits, so all that they have adjusted and got. And findings so far, I think there are so many findings which were not seen earlier. They were all found out, some Carina nebula, WASP, and like this different nebulae, and up to 290 million light years from Earth. That is the type of distance that is there. All these objects it could detect, and it is totally changing the understanding of the universe. Even number of black holes that it has now detected, it shows, it looks like currently they are feeling that it is 10 times larger than whatever, sir can correct me, okay, 10 times larger than whatever we till now were thinking. And this was the just 2 days back, I think, in newspaper it found a picture, and in the middle you see there is a question mark. This is some nebula or something which James Webb Space. So it is like questioning us, who am I, you find out, or whatever, something like that. So James Webb Space Telescope has left a question mark to the humanity. You people, human beings, think that you are the most intelligent species on Earth or universe or whatever, but so these are formed some billions of years back, okay. So who am I? That is what it is questioning. I think some of the ISRO students should find answer, okay. You will be able to find somebody studying sun, somebody, okay, right. Now I will come to the Chandrayaan, the most awaited topic, the Indian quest for the moon. So I will be faster. The history of lunar missions, because before knowing ours, first we should know, because so much media hypes up so much, because they want to have some news to sell. At the same time, the facts also people have to understand clearly. Everything in moon, the first thing is done by Soviet Union. Not only moon, space, anything in space, the first thing is done by the Soviet Union. So 20 successful missions they have done and have number of lunar firsts. So first probe to impact the moon, the first flyby means just it goes by that, and the image of lunar far side is because this is rotating, okay, one revolution and rotation, both are there. One is rotating around itself and rotating around the earth. So but the rotation rate and the revolutionary rate both are same. Because of that we cannot see the other, not that any other reason, but because of this we cannot see the other side of the moon. From earth if you see, always you are seeing, so but Russia was the first who have seen the other side of moon and they have taken the photograph. First soft landing, impact is one thing, just go and hit it. We also have done lunar impact probe. So, and first circumlunar probe was there which went there and returned to earth also, okay. These are all Russia has done. The 2 successful series of Soviet probes for 24 lunar missions they have done. Now lunar 25, just maybe a few days back they have launched, which is again media hypes unnecessarily. There is nothing like a race, okay. It is anant, space is anant. Who are we to tell that I am competing with you? Aap ek jagah dekho, wo aur ek jagah dekhenge. Both scientists have no problem, but the problem is for the media only. They hype unnecessarily. We need not fall to that at least, okay. So first after they are going and here the main thing is out of 20 missions you can see 11 landing attempts failed for Russia because their thing is different. They were doing it first time, pioneering they call. They were pioneers in space technology. Whoever is doing first time, whoever gone to Everest, there may be so many people who would have died before Tenzing Norgay has succeeded. It doesn't mean that their thing was less or Tenzing Norgay is alone great. He succeeded first, but before that, for every success, the failure is the one which teaches you how to go further. So that's how they have done. And United States, if you take 58 to 65, 7 years of time, they tried 14 missions and all 14 have failed. Okay. Why I am telling all this is to put the understanding in the perspective. Tomorrow anything happens also, we should be able to know the complexity of this mission. I'll tell why it is complex also. So 2 of them are partially successful and next 3 impact missions were successful. Afterwards, okay, there was no stopping US, and actually US is the only country who have landed men on the moon, men. So that is there. Out of 24 astronauts have traveled to the moon, all from US only, and 12 walked on the surface in 6 Apollo missions. And now after in between they lost interest because they have done everything. But now because China and all that coming or futuristic thing, they are stating Artemis mission, okay, where once it is successful, they will be able to establish some lunar stations for research. And just one interesting bit is President Nixon, first Apollo mission, when Neil Armstrong and all were landing, he had a speech writer. One speech he got asked them to keep ready in case these 2 astronauts do not return and get marooned on the moon. He has to deliver the speech. All of you have, I think most of you might have heard Prime Minister's speech after Chandrayaan failure. I think if it is successful, the speech would not have been so powerful, okay. It was such a powerful message he has given in that, going to the basics of science, how scientists will. So it was such a beautiful, because I heard from this distance, so it was really a very powerful message. So here also Nixon had luckily the rest of the world need not hear that message, so we don't know what was written in that speech, okay. So and People's Republic of China, we have to credit, we may be our rivals and all that, borders any 2 countries that is there, but technically you have to accept they have done 6 successful missions. All 6 are successful, okay. All the 6 missions of China are successful and they call it Chang'e missions. Chang'e is like our Chandamama. For them, in their language, Chang'e is the goddess of moon. And first landing they have done in 2013 and they did sample returns. So the robotic mission they did, the samples they have brought back of 1.73 kgs of lunar soil, they brought back and distributed all over the world like that. And first country to land on the far side of the moon, Russia took pictures, but landing, Chinese have done it. And extended life beyond a lunar day. This is another thing which you hear about Chandrayaan. because lunar days, like Earth day is 24 hours, lunar day is 14 Earth days. Okay. So beyond that, what will happen? Sun will be, I think, not there, and it will be eclipsed. So it becomes dead cold. But there are missions, 6 months and all that they do. But there you need a nuclear energy. So radioisotopes and all will be there. They will be producing RTG and heat generation and all. They will be doing to keep it warm during that time. And after lunar day is over, night is over, again after 14 days. But we are having some hope, but that is not the primary target. And we don't have nuclear source right now in our Chandrayaan-3 mission. But Russia has done all this, China has done all this. And they are planning crude landing on the moon by 2030. And they are tying up with Russia to set up an international lunar space research station. Now, why it is so challenging? Moon landing mission, why it is difficult? There are so many missions which we are doing successfully in space. So, first one is the distance of the moon, 384,000 kilometers away from the Earth, and needs enormous energy to reach there. Okay, either by rocket or you go in propel like what we are doing. And translunar injection and lunar capture, recently so much TVs have told. So how do you go? Exactly at that point, you should be able to reduce the velocity. Thoda jada engine fire hua, so you will go out of this planetary system or at least away from both Earth and Moon influence. And thoda engine kam hua, so whatever fuel you are having, some efficiency will go out. So the amount of fuel, and another important problem in the moon thing is, why you have to use only fuel? Normally, other recovery missions and all, we are seeing parachutes. Through parachute they land. In moon we cannot land with parachute because there is no atmosphere on the moon. Venus or something are different. They may be hostile, but some atmosphere is there. Here we cannot use parachutes. That's why we have to totally depend on engines. Once you are using such powerful engines, you should be able to control them to, when we are about to land, the velocity has to come down from few hundreds of meters per second to 0.5 meter per second of such a 1700 kg. So how do you control? So that is the major challenging portion. And distance, because of the distance, the communication, because the signal levels are so poor, how to keep your orientation of your antennas, that is another part. And design for harsh lunar environment, testing under the lunar environment. So many special tests are done for Chandrayaan. So many special tests. All over India, different facilities of Army, Navy, Air Force, all the facilities are used. We do helicopter testing, we do some, helicopter has to test some sensors and all. Helicopter has made some 25 sorties they have made. So like that various tests have to be done. And at Chandigarh also we are having like that, because they do it for ammunition and all that kind of, some guns and all those kind of testing. So those places also, because you have to decelerate from a very high speed to a, so all those the testing and all those things have to be done. And landing leg design, because it has to withstand the probe when it is landing on the moon, the legs have to withstand the impact. And it should not pass on the vibration to the systems, otherwise they will go bad. So it has to get crushed without further transmitting the impact. So that is another important point. So this leg design and different slope, you don't know where you are exact, now okay we know, but so how do you land, okay, those things and all are important. Sight, boulders are there, or if there is a ditch, so how do you, all those things have to be taken care. And what we are doing is, we have a camera, OHRC, this was in Chandrayaan-2 mission, which is in the orbiter, that is giving the world's best pictures, we all can be proud of. The world's best resolution pictures of the moon are done by Chandrayaan-1, okay. Even America, if they want to do some mission, now they will take images of OHRC and they decide the landing sites and all, because the best resolution picture is made by Chandrayaan. Not that others cannot do, it's all question of resources, no. So when we did, we have flown at that time, and till today, that is the best instrument, okay. And landing leg design and trade-off between fuel and payload, this is the most important aspect. You want to do some important experiments. For that you need some cameras, which we call as payload, which is paying, no, for the whole thing. So that is important thing. So we have to make trade-off. If you are putting more payload, fuel will come down. But if you put too much fuel, payload will, that trade-off is very, very important. And anything you do on lander, okay, 1 kg if you add on the orbit or propulsion module which has to take it there, you have to add 2 kg more fuel, because it has to lift this fellow and take there. So for that, so like that 3 kg, 1 kg if you want 3 kg of fuel, rocket has to lift more. So this is how the design gets complicated. And recent Japanese probe, whichever has crashed, they were just few seconds away from the landing. At that time, their sensor misbehaved, and their, because of that, fuel got emptied, and in the last seconds, snatching victory from jaws of defeat, they tell, here it happened with the reverse. They had defeated the, almost it was done, okay. At that time, because fuel was over, it crashed. So this is another very difficult portion of the whole design. Then highly accurate sensors. We have to the level of accuracy of velocity to few millimeters per second. That is the type of velocity it has to measure, and same sensor or some other sensor has to measure initially when some hundreds of meters per second is there. So this range, how do you accommodate? And acceleration has to be sensed, the height has to be sensed, and as you are coming closer, some radar instruments are there, so how you are coming close, because at half meter, if you make an error of 600 meters, you assume, half meter, 600 centimeters if you make, you are hitting. Or if you make other side, it will fly away, okay. So these are all the precise instruments which have to be developed. And guidance and navigation. Here GPS is there. In moon, there is GPS satellite signals will not reach. So where are you going? How do you guide yourself? For that, lot of instruments have to be flown. We take actually from OHRC, images are fed. So those things are seen and they are pre-stored there. So accordingly you are able to guide it towards that and see where you are. And mission planning, when you have to launch will be, why we have to launch on this particular day only, recently injection done, because we are going to be there only for 14 days and we would like to launch on the very first day of lunar day. If you go on 3rd day or 4th day, 4 days of opportunity for studies is lost. So first day if you have to land, then accordingly you have to back calculate, okay. Accordingly the launch vehicle has to lift off from ground. So all those things, and launch window, some plus minus 10 minutes, half an hour. If it crosses that, you cannot launch on that day. Next day you have to go, then all mission parameters will change. And if you shift by, for whatever reason, say 10 days or slippage comes, next opportunity may be 6 months later. If you are having lot of fuel, that is different, okay. But here, because we loaded certain amount of fuel, within those constraints we have to work, that makes it most difficult. Then power generation, that is another important thing, and how to orient towards sun, the sun aspect angle. Even the area you want to study on the moon, the sun angle has to be certain angle. So all these things decide the mission. And rover design is another important. On lunar surface, we have to rove. This is now like a vehicle you have to drive, and different surfaces. The lunar soil that itself, we will simulate. That soil itself is filled in an area of this kind, maybe double this area, okay. So all that sand, the lunar soil, that itself will cost a few crores, okay, to make it and to have same texture, same properties, all those things have to be done. And of course project management, any project of this kind of thing needs a very good latest modern management techniques. So these are all the moon missions so far. As you can see, United States is the only one who has done crewed landing. Russia and China have done landing, rover and return also successfully. Japan and India have done the impact, but not succeeded in landing yet. And ESA, that is European Space Agency and all, also up to impact. And United Arab Emirates, they also have done, okay. And Israel, Luxembourg, it's a very small country in Europe, okay. They have also done up to that. And South Korea and Italy. Italy has done just a flyby mission. South Korea has orbited also around. So these are all the locations, because again people tell we are the only people going there and all. So there are all the parts of moon is quite sufficiently explored, okay. So this is another. So now I will come to our own missions. First I gave you a backdrop of what was the internationally, what was the history of lunar landings, why the lunar things are challenging. And now we will come to our mission. Very briefly, Chandrayaan-1 was launched by PSLV in October 22, 2008, and only orbiter is weighing around 590 kg. Okay, moon impact probe, and Chandrayaan-2. Okay, and most important part of Chandrayaan-1 was the data received from our probe. Those so many missions were done earlier by. This has confirmed the presence of traces of water on the moon. Not really reverse like that, but some traces. Okay, sir may be able to explain better how do they sense that and all that. So that traces it could confirm. That was the important discovery of Chandrayaan-1. And in Chandrayaan-2, it is interesting actually. We wanted to do it with, along with Russia actually, Roscosmos. And Indians, we were on schedule in whatever agreed portions. Russia will do some portion, we will do some portions. But Russians lagged behind in lander development and withdrew in 2012 as they at that time one Mars mission they have done, Phobos, which failed. And same technologies had to be used in their lunar mission also. Because they failed, they told that by the agreed time we cannot do, it will take more time. Then India has taken, maybe it is a blessing in disguise. So we took our own path and our government has given a directive to do it ourselves. So India has done, but the hardware which was developed at that time for Chandrayaan was diverted to Mangalyaan. Because Mangalyaan had a very unique opportunity around that time. If you miss it, again for so many decades you will not get the opportunity. So Mangalyaan was launched using that hardware. And okay, orbiter weight and all those factors are there. All these things you will get in internet, okay. So that's okay. 2379 and rover was there. Unfortunately, okay, and as I told, OHRC remains the best in the world camera to date, which has mapped the moon. Okay, and Vikram lander operations went smooth till last few minutes, and just 2.1 kilometers above the lunar surface, it deviated from the track, okay, due to combination of errors, like Lord Karna, when he dies, they will ask, then at that time he will tell, Krishna will tell to, in Telugu poem I know, Naravara Niche Nache Varamadagina Kunti Cheta Vasuki Chetan, like that. So Arjuna, it is due to me, due to you, due to the king Indra, then his own mother Kunti who has asked, like this there are 7 reasons for Karna's death. Like that Chandrayaan also, why it failed means, it's not just one, some 4 or 5 reasons are there. Out of that 5, if any one has not happened, we would have become successful. That is the fate, okay, whatever we call. Finally, why do they pray, all these things? It is for that, seeing that, otherwise out of these 5 causes, any one of them has not happened, Chandrayaan-2 would have been successful, okay. Even if other 4 happened, it is okay. Other thing, but all the things have happened at that moment, it happened, but that is technology. That's why it is challenging. Otherwise, everybody would have done by now, okay. So that is the thing, and orbiter is continuing its journey today also, and I am sure that it will go much beyond its design life. And one collision avoidance maneuver. NASA has, like our orbiter, LRO, Lunar Reconnaissance Orbiter is there. So NASA, and sometimes that can come so close. So we have done one maneuver to see that these two will not hit each other, okay. So this was not Chandrayaan photograph, okay, but some other launch initially, SLVs when they failed. You can see the gloomy nature, but as I told, musibaton ko dekhkar muskurana, mrityu ko dekhkar uchalna. So we should never worry about what has happened. You have to, of course, at that moment the faces will be there, but you have to, how quickly you come out of that gloomy mode. Forget what hurt you, but never forget what it taught you. So you have to learn from our failures and move ahead. That is what ISRO has done to move from Chandrayaan-2 to Chandrayaan-3. Okay, we are at the very crucial crossroads now. And sir is already doing Namaskar, he is praying now for the success of Chandrayaan-3. So mission objective is to demonstrate safe and soft landing. Earlier we had some precise and some words I think. Now it is safe and soft because according to situation we have to slightly tailor our objectives, and rover operations as additional objective. And no orbiter here because we are having the world's best camera. Why you have to repeat the, instead of that effort you put it in fuel, okay. So you get better chances of success for this mission. That is what is done. And it carries lander and rover till 100 kilometer. I think mission profile, our TV channels have made it so popular. more than ISRO people, I am sure no general public knows better. Okay. Yesterday, Sandeep was explaining me how we use this lunar assist and all to meet. I was really happy because this is what media can make it or break it. Okay. So the power is in their hands. So how we use it, but it is good that after cricket and maybe Bollywood, Chandrayaan-2 could unite so many Indians, at least few crores of them were watching at the night, waking up and seeing after Cricket World Cup maybe. So propulsion module here the weight is 2148, typically 2/3 or something like that will go for fuel, 1700 and 758 watts of power. Lander and rover will weigh 1752 kg, again 1000 kg fuel. So of course these dates and all and 23rd August, all God willing, I am sure we should be able to land, and the life is for one lunar day. If we survive beyond lunar day, it's a bonus, okay. That is not the mission objective, but if we survive, yes, good, then we can claim. If successful, India will be the 4th country to achieve the milestone. It's not that I am pessimist, but being from a scientific community, we have to put things in proper perspective, okay. So lander instruments, Chandra's surface thermophysical experiment CHASE will measure the thermal conductivity. Basic idea is to understand the formation of these planets, whether life supporting environment is there, whether if you want to colonize in future, what are the things that we have to do. Whoever does experiments, it's all with that. Accordingly, the instruments are flown, and in rover also this. So, and is there anything beyond Chandrayaan? So that also beyond Chandrayaan-3, there is a mission called LUPEX mission for India, I am telling. This is a lunar polar exploration. The pole regions, top and bottom, both, but south is most attractive. This is very, very interesting for the scientists because they feel that some of those areas are permanently shadowed. So there they can see the formation of ice and all those things, the original formation, and it is of lot of scientific interest. That's why this year the Japan will make the lander, which will go there and dig the instruments, and payloads are there from both the countries. Launch vehicle and rover is from Japan, lander is from India. Lander has to be, of course, much more capable than Chandrayaan-3. It has to be. It is not scaling up also. It's a totally new design like that we have to do. And the rover will explore permanently shadowed regions of Moon. Overall mass of 6000 kg. Payload mass with rover is 350 kg. But all this is basically subject to approval of the governments because so much public money expenditure is involved, and the confidence, of course, it's all diplomatic channels also will be there. So all those things it will happen. Then of course in this picture, I am sure, like in Sholay pictures, Galli Galle mein Bachcha Janta Hai, like that I think this picture is now known to everybody, how we are moving first, going around, raising around Earth, the orbit slowly, then the most criticality is here. How you exactly reduce the speed at the right point. As I told, any small error there, either you may fly by or you may crash, okay, or you may lose the fuel. So that is the thing which is being done. So though we have come a long way, we still believe, and it's true, space will not forgive you if you make mistakes. So in spite of whatever we may do, we have to guard, and when thousands of people were working on the mission, any smallest error anywhere which has not been brought out by the amount of testing we have done on ground is a potential for trouble, okay. So that's why we build so much of systems engineering practices to see that these mistakes are eliminated, and even if they are there, they are caught on the ground itself. So this is I used to tell in some other context, but I think I'll still tell. This is what actually first for our engineering, our induction program, when new ISRO recruitees, for them I had to give a lecture, all the things on reliability and quality, because I am not a scientist nor a designer also. I did most of my life I spent in reliability and quality assurance. Actually I should, Chandrayaan-2 certification that it can fly was signed by me, okay. Okay, but okay, whatever happened that time. So Chandrayaan-2, not 3, okay. So, but still this quality rhyme I told, at that time I was telling them about importance of quality in space systems. I had all the slides, I was just thinking, at that time how to close my presentation. My son, he was very young, I think he was in, at that time this PowerPoint and all were not there also. He was singing in bathroom actually. Oh mummy, please give me some vegetable soup to make me grow strong from my head to my toe. C for carrot, B for beetroot, T for tomato too, to make me grow strong from my head to my toe. P for peas, B for beans, P for potato too. Cook them all together and make me some soup. Make it yummy, make it tasty, make it delicious too. I will drink it up all to the very last drop. You may be wondering what a soup has got to do with Chandrayaan mission or a space product, and you are telling quality, named quality rhyme name is given by me. Then when he just came out, I asked, you give me that rhyme. They gave, what is it, cyclostyle sheets at that time. I took, and in the bus I was sitting and seeing through. Then something flashed to me. Here if you really see, there is a customer, the child, whoever is singing the song, and there is a supplier, the mummy, and there is a product, the vegetable soup. And there are functional specifications. The soup has to be yummy, tasty and delicious. These are the functional specifications of the product. But what for you are doing all this? There is a mission goal to make me grow strong from my head to my toe. So the mission goal, whatever we are doing, we have to keep reminding ourselves. That's why that actually to fit it in a slide, maybe I removed, but otherwise it keeps repeating in that slide, okay, in that rhyme. So your mission goal has to be clear, and you have to keep on reminding yourself, as long as you are focused on your goal, rest of the things will follow. Then what is this carrot, beetroot and all? So there is something called declared parts list. So you can use parts, preferred parts list we call. Only those parts can be used in a spacecraft building. We cannot put any latest electronic device and put, because they are not tested for space. They have to be qualified. So here I call this carrot, beetroot, tomato or declared parts list. So only those you can use. And there is a declared material list. If you want to use steel, you can use maybe titanium in some particular application. If temperature range is this much, you can use it. Beyond this, you cannot use. Like that, there are so many restrictions. We call declared material list. So that is whatever piece, you cannot bring brinjal and do, because customer has not specified. Okay. And then there is a declared process list we call. How to do every process in a spacecraft. If you just want to put one temperature sensor on a wood, the way you do the process is different. If you want to put it on a steel, the process is different. If you want to put it on a composite material, the process is different. So the process is different. So there is a declared process list. For every process actually we made something called, I have not touched it because time is already exceeded, process identification document. Sirf aapko kuch karna hai, like painter itself you take. How many steps are there before painting? First he will come, cleaning, not once cleaning, twice cleaning or 3 times cleaning. Then putty he will do. Over the putty, second time putty, then again smoothing. Then again, all this is documented in a process. So same way, but you change anything, the wall is concrete wall, it may be one procedure. If it is cement wall, if it is some other. So like that, all the processes are catalogued. So here the process is cook them all together. You cannot cook them separately. So like that, declared process. Finally, I will drink it up all to the very last drop. Yesterday, Dr. Mundraji was telling to my son, day before yesterday, I think, in his office. Somebody has told that you have to live your life till the last leaf. Sir will tell better, okay, till the last this one, like that. Same way, the theoretical life of a spacecraft is defined by the amount of fuel. Why the Japanese lost their vehicle? Because the vehicle fuel was lost, okay. Or a 15 years communication mission, if we tell, when it will work for 15 years, when all its sensors, control systems, structure should not break up before this 15 years, or the fuel should not leak before 15 years. So everything have to, like that, all systems have to work. Like Hero Honda, they used to tell, fill it, shut it and forget it. You can forget till the fuel is there, okay. Okay, he says you can go longer distance, but so here till I'll drink it up, the most important specification is the reliability. We want the mission to do all the functions it was doing on the first day of the mission on the 15th year's completion. That can be done only when we when we adhere to the reliability and quality assurance practices, system engineering practices, and the rigor which we maintain, and actually the spirit of doing it correctly, the doing it first time right, that spirit should be company-wide quality control they call, should be spread from ISRO chairman to the last level of person. For me, all are equal. It's not that chairman is something high or a helper is something low. I feel all human beings are same, okay? But everybody is given their functional role. But everybody in the hierarchy from top to the bottom should be knowing the objective for which we are working and the importance of what we are doing, how it can impact the whole mission. If this spirit is ingrained, then automatically missions will be successful, and I am sure this was Mars mission. Similar movement we are going to see for Chandrayaan 3. This is what we hope. So I showed you a picture where bleak faces were there and where all happy faces. These are part of life. Not just Chandrayaan or Mangalyaan or anything like that. Life also one day will have a happy moment, especially youngsters. No need to get distressed. Yesterday night sir was telling how he stayed in a labor room in Baghdad. Okay, CEO of a company staying in a labor room because of the war situation and all. So this is the adaptation. We should be able to take success and failure, equanimity. That comes with exposure. More and more, some events like this are held, more and more knowledge exchange happens, more and more experiences are shared. Definitely it will give a good footing. I am sure Samsad is doing a extremely good job. I am really, sir, thank you very much, Dr. Munraji, once again for enabling this kind of intellectual gathering. And I was watching, again I will come to madam, you madam, started with you, all of you there, that row, okay, all 5 of you, sir and madam. They were watching with same interest. Sometimes youngsters, when I am teaching, I can see 1 or 2 talking here and there. They were totally focused on the slides or on my face. So this is a thing I have learnt a lot, okay, by observing some of you elder people and here sirs are there. So really it's a very great learning for me, and I think I derived a lot of pleasure in this particular interaction. Thank you very much for enabling it. And before moving to questions, or if at all it is there, I want to recollect what Sir Isaac Newton has said. What we know is a drop. What we don't know is an ocean. This is told by Newton, whom at least I consider as for me he is the greatest scientist on earth, because he has done no field which is untouched. If he is saying that, I think, sir, it is not fair for you to tell me as a whatever giant and all. I am much small person. So that is why I look small only. So thank you very much. And so questions, I will be telling now itself. I have
before you ask, I think
Yes,
you
sir.
should take your seat first.
Yes, sir.
You're for standing for
Yeah,
1.5 hours.
I just wanted water.
Yeah, water. A little bit of water. Yeah, first of all, I should mention before the questions answer session that at least to me, and I personally feel for quite a number of people in the audience today, it was a tremendously illuminating talk. Why illuminating? We general people, we are always excited, sometimes a little disappointed when we succeed or we don't succeed in a space mission. We feel proud. And these are because of our perceptions that were built mostly by the media. We hardly go into the technical details of a space mission or the process, the method, the methodology of sending a spacecraft successfully, at least trying to put it successfully in an orbit or around some object in the sky. Today, Professor Rao's lecture gave us a brilliant hint of how tough, how detailed, how precise, and how professional is the approach of technocrats, technicians, engineers, scientists, and policymakers to make ISRO as successful as we see it today. So that particular perception has sort of grown up, that it is not just, oh, it has going like this and they didn't go like that, and it will land and India become the 4th country. It's not just that. to them, it does not matter initially whether it is 4th country or the 40th country. To them, what it matters, we should succeed in what we are doing. That is a tremendous lesson, at least for the younger generation. Not the objective or the effect of my success, what will happen, whether I will get $10,000 or get a new car or buy another house, but rather what I'm trying to achieve through my work. That is a tremendous lesson. I had the good opportunity of meeting quite a number of chairmen of ISRO, Madhavan Nair, Kasturi Rangan, then Ramakrishnan, and also not chairman of ISRO, APJ Abdul Kalam, who was a very close friend to me for 10 years. And I have found in everybody, they were so humble in telling about the achievements, but they were so powerful in telling about the process, methodologies, the ideas, the vision. That is a learning experience. We all try to talk too much about how good I am, how good is my work, and how good everybody will sort of talk about my work. We never talk about the methods that we take. Right? That is a lesson. And another part of the lesson I got is that it is just not some information, some knowledge that he transferred. It is a glimpse of his wisdom also. One example I will give you, it's very non-technical. The last poem, he spoke how his son was singing and he thought it and heard it. But have you realized what he said later? You see, this is the problem of the supplier and the client. At that moment, he is not thinking it is his son and his wife who is giving this. He spoke supplier and the client and the product. That is a glimpse of a scientific mind. It takes you out of your regularity, regular life, and puts you on a plane, on your mental level, which takes things very analytically, objectively. That is one lesson of how to do science or how to think about science. It is not that, oh, Russia is winning over India because it will land on 21st of August instead of India landing on 23rd of August. Science doesn't have this boundary feeling. Yesterday I found in the new media, somebody is saying, a lot of media, see, okay, let Russia land, but Russia is India's friend, right? So friends landing. I just wrote somewhere, so if it was Pakistan which was landing, we would have started a war. Right. That's absurd. So it gives us a glimpse of science, the glory of science, the achievement of science, and how science should be done. Thank you, Professor Rao, from the core of my heart. Now questions. Yeah, first one, I think.
My 100th salutation to Dr. Rao this day. There are so many questions coming in my mind, but few of these is this. Number one, America, Russia, China, and Japan, their target of landing moon, the time is very much less than India. The reason is that, is it the financial aspect or the security of success? What is this? Number one is my question. Second one is that there is a conception, the outside surface of the Chandrayaan-3 is with gold. Is it a fact? Number two. Number three is that, third question is that, is there any solar panel is used for the power required by Chandrayaan-3? And what are the fuels used by America, China, Russia, and Japan? And last one for this time being is the existence of Chandrayaan-3 in moon is only 14 days. But Luna 25 is much more than that time. Now, for the timing, this is my questions. I'll be very glad if it is explained properly. Thank you.
Thank you.
I think I have mic.
Oh, yeah.
It's there. Sir, the very first question you have asked was about the time taken. It is due to the power of the launch vehicle. I told in the beginning itself in the space, the constraints imposed by launch vehicle. They are having very, very powerful launch vehicles. Of course, we are also very good in launch vehicles. To the extent we have developed, we have done some world record also of launching 104 satellites, but the mass which a rocket can lift is much, much, much higher even in the Apollo time for the American rockets. They are having tremendous lift-off power. Because of that, they are able to take the probe or whatever satellite very close to the lunar surface and from there. But we are having a vehicle which is not so powerful, so we can inject it up to certain height only. So from there we have used the ingenious method. Of course, it's not that we have invented the method. Whatever Voyager probes and all are there, they have used this method earlier. But we have used, because when you are constrained, your process also will come out. No, our own. When you are having constraints, we find a way to make it happen. So we used the principle of whatever that several rule, some jumping, and then go, so that it will become an efficient method. But in a one word answer, if I have to tell, it is due to the power of their launch vehicles. They are able to do it faster because launch vehicle directly lifting. Bahubali is there. So, but whereas ours is Bahubali, they may be having Bahubali 6, we are having Bahubali 2, okay. So that is the reason why, that is one thing. And then coming to the solar powers, solar panels portion, yes sir. Anywhere, any space systems, except Voyager like probes, otherwise they are all powered by solar panels, okay. That's why that is one of the constraints also, how much area you can put, how much is the weight of the solar panel. If you increase the power generation by putting a higher panel, then the problem will, you will lose the payload. Okay, those optimizations are done. But simple answer to your question is, yes, there is solar panel, but sun is not always there. When sun is not there, this energy has to be, the generated power, just like our house inverter, when let's say West Bengal power supply is there, the inverter is getting, your battery in the inverter is getting charged. So same way in spacecrafts also, we have got batteries of different capacity. For a 15-year mission like communication where it has to support kilowatts of power, huge batteries will be there. For Chandrayaan and all, smaller battery pack is sufficient. So that battery, when sun is there, battery will be, this is supporting spacecraft plus charging the battery. When sun is not there, this. Then about the life you told correctly. So 14 days is because of the, not that we cannot, but the systems go dead cold after the 14 days because lunar eclipse will come. At that time, 14 days, it will be dead cold. So you have to keep the heat. If you can put अच्छा चादर डाल के उसको अंदर कुछ किया तो ठीक है. But for that, what they do is radioactively you have to heat. Radioactive heat sources are there. Sir may be able to tell more on them. So that heat sources, if you are India, we have not done because one is we are developing now almost, I don't know I can declare or not, but we have almost in the, along with the BARC, we are in the, we are, I think maybe next missions may come, but I am, please don't this to me, to anybody, because still last stages, unless you test it and qualify for space, doing on ground is different, doing in space is different, still lot of steps are there, but we are attempting that. But they are all having those radioisotopes. So there two portions are there. One is to heat it, one is to generation of power itself using radioactive sources. So first step will be heating. So this 14 days, if you can keep the critical systems, whole spacecraft need not be done, but critical systems, if you can keep them warm enough at least, after 14 days, you can use your, again power is generated through solar panel, you try to heat it and then come back and see. But systems have to withstand whatever lower things, so some things are done. That is the reason why they are. And with Japan, whatever we are doing joint mission, it will be there for 7 months. Earth days, I am telling, Earth months of 7. 7 months it will be there. So that is one. And I think one you asked about whether lunar surface is gold or not or something like that. So you answer. Yeah. So,
yeah, basically, it's not the lunar surface. What he asked is that you see about Mangaljaan, Chandrayaan, now, when you see it, the module, it is yellow colored. So people wonder what is that yellow color, why it is always yellow. And some people say it is gold. It is not pure gold, but it is a material, a polymer, which is impregnated with 24 karat gold. Why? Because in our class 11 science, we have learnt about something called Rutherford-Goldif experiment, which says that alpha particles, helium nuclei, if they are bombarded, gold will actually deflect them. So from the sun, huge number of powerful alpha particles always come out, in addition to other things. So they can punch a hole in the skin of the satellite and do a lot of damage to the electronics inside. So at some initial level, there is a barrier so that they can get deflected. That is my understanding. But there may be
Sir, thank you for your.
Right.
I want to thank Munraji for having Mr. Duvar, Dr. Duvari as the chairman of the session, because we can complement each other. So that is one advantage. Because science, I am a zero. So wherever technology and science, he brought, sir, that's why I called him a visionary, because he brought them, not you, sir, I'm telling about Munraji. He is a visionary who brought scientists and technologists together. But sir, now technical side answer I will tell. That is called multi-layer insulation, MLI. Space, when a spacecraft in the orbit, when it sees sun, it is getting heated. When it is deep space is 4 degree Kelvin, that is minus 269 degrees centigrade temperature. Lowest temperature Delhi sees is maybe okay, Jammu and Kashmir also -5, -6, something. This goes to minus 269 degrees is space temperature. So spacecraft, when it is not seeing the sun, everything will become dead cold. So you have to, then the way we are putting sweaters, this is multi-layer insulation. Actually that is the passive control. One is to put active heat, but already you do not have sun. So solar panels are not generating power. Battery you cannot waste for heating. So this insulation itself, so like low Earth orbit satellites, they were for 60 minutes in sun and 30 minutes in eclipse, or 23 minutes, 24 minutes, like that. So at that time, this will provide the warmth and will not allow the inside heat to go out, like sweater. So that is something equivalent to that, in addition to whatever sir has told.
Dr. Mundra wants to make some comments, I think. Yes, please.
Comments, okay sir, your questions I cannot answer. All right, sir is standing, how I can sit? Okay sir.
When I get the opportunity of having Kalpavriksha with me, before me, I am tempted. But I will ask you a simple question. I heard that Chandrayaan 2 is still, there is some life in it. And I think yesterday or day before yesterday I saw that they discovered there is some argon gas in lunar, very thin atmosphere. Is it true?
I have not heard, sir, you have any.
Actually, they have found traces of argon, but they have to do a much more detailed spectroscopic analysis to find out whether it is actual and whether the column density or the abundance, fractional abundance is quite appreciable. That much I was reading about it. And finding argon gas will be quite an interesting phenomena. And apart from helium-3 on the ground, which is a game changer if they are found, argon-3 can also play a lot of scientific roles on that.
Because I knew up to water traces only, sir. Argon I am hearing.
Yeah, you knew about water traces.
That was.
Because when people are thinking
it is published also.
of colonizing moon, a lot of things will be required.
Yeah, a lot of things have to be done. Till then, suit they will wear, sir. Right now, it's not that we cannot go. You have to, once you wear space suit, okay, they will be able to do anything.
Yeah, but the resources are required.
Yes.
I think I should give opportunity first to the audience. But one thing I would like to add, Dr. Duwari has kindly consented and given us the opportunity of his vast scientific knowledge and vast technical knowledge. Two, we are very fortunate that the two are combined today.
Will come.
The one word which I was about to come out, which Dr. Dwari has snatched from me, such a knowledgeable people we are having in the entire section. Sir, you kindly be seated. Be
Sir, I am comfortable.
kindly.
Okay, fine.
Yeah. The simple and with such a honest and such a humble approach of you, I mean, this is what, and then you use the word teamwork, whether from a worker till the topmost level, this is the team which we talk about. So I'm a commerce student, nowhere near to even 1% of the knowledge which is prevailing here. What I'm saying, we are from a Tapobhumi, Devbhumi, and we call it Chandamama, which you use also. Yes. And you covered your answer within what I had little sensei and doubt. You say, if you do any mistake, space will not leave us. You said that. Yes. You said that. But still I'm saying, we call it a Chandamama. We are in Prithvi. तो हम उनके बहन के बेटा बेटी हैं उनकी बहन के वी आर ट्राइंग टू गो मे बी चंदा मामा के उसके पैलेस है उसके आउटर रिंग में वी आर गोइंग आई मीन एंटायर वर्ल्ड इज गोइंग इंक्लूडिंग इंडिया इज गोइंग तो सबसे बच्चे आ रहे हैं बहन के बच्चे आ रहे हैं खेलने दो हाउ मच यू आर गेटिंग रिलेटेड विथ आवर भागवतम गीता और वेद शास्त्र हाउ मच इट इज गेटिंग रिलेटेड with those figures which we read in our Bhagavatam, we read from our, we hear from our sages, are that has got any relationship, or your science has got independent, nothing to relate with our scriptures, what we are thinking. And the entire, any relationship is there between this, or you think that tomorrow, I mean, what we are doing it may have other implications.
Okay, first, scientifically, I want to correct one thing, sir. We are thinking moon is and a bigger thing you are putting, but scientifically, moon is satellite of Earth. Moon is rotating around, like Earth rotates around the sun, moon is rotating around the Earth. So the moon's its own existence or whatever its stability is dependent because of the Earth. That is a scientific interpretation. Other things are okay, philosophical or and regarding the research in astronomy, I think, sir, you can tell.
The existence-wise, moon was born out of Earth.
Yes.
Because 4.52 billion years back, 452 crore years back, scientists believe a huge ball of rock came and smashed onto the Earth. Huge amount of material got thrown out into space. It couldn't go away forever. For millions of years, it condensed, coagulated, and coalesced, and gave birth to the moon. This is called the giant impact theory or the collision ejection theory. So in that sense, from science language, I will say, moon was partly a part of the Earth, and that object was also there. This is believed by 99% of the scientists. And you'll be amazed to know, moon has affected Earth. Because of that collision, scientists believe, Earth got tilted by 23.5 degrees, which causes seasons. And only for seasons, you are all sitting here now. Because it is for the change of seasons, ocean currents change, air currents change, clouds are born somewhere, gathered somewhere else, and gave us rain and fresh water. So these are all interrelated but connected, and scientists believe they more or less know the truth, more or less. No, I don't think the time has come for our intellect to link up the scriptures with these discoveries, because we are far ahead in our understanding in a scientific sense, but in the scripture sense, we believe in faiths and perception without going into concrete details. That's why.
Good noon, everybody. Myself, Professor Pramod Ranjan Nandi of West Bengal University of Animal Fisheries Science. Professor Duwari is here. He is my teacher also, as I have completed one evening course on astronomy when he was in, it is not, I won't raise any question, just one small sharing, that I am the professor of biological science, that what we have evolved in the laboratory, that for lab to land program, and some experience of land again come to the lab also. like was in physical science, that is the space science. I don't think it is the part of physical science or earth science might be. But what success story or the evolved, which are being evolved, that our glory, success, that to be popularized. I am telling about the popularization of science. In our school days, when we have participated in the debate that whether the atom bomb is for boon or atomic science is boon for boon or success. Likewise, here that program to be run in the college level and school level about the popularization of science and especially the space science. Okay, thank you.
Professor Rao, you have something to say about it? I think he just made a statement.
Yeah.
Yeah, I think popularization is needed at all levels, first of all. And whether it is a boon or a sort of curse, I think every aspect has two sides. I can manufacture number of boons, I can manufacture number of cars. If I don't like the thing, I can just say I don't like it. So that is not the debate here. The debate here is how we are proceeding forward. Just one.
I just want to add, I think missions like Chandrayaan, many people question, for India like country, do we need mission like Chandrayaan, Mangalyaan? But we have seen that it aroused the interest in from auto rickshaw driver to an institute professor like that. So that is the thing. I think these are the types of things. From here, further popularization will take over. It will take off from here.
And in continuation,
once it is success, the interest it generates in the youth.
Right.
Your point is exactly correct, but it will be automatic. It will be spin-off. So then all your hundreds of millions of dollars, whatever you have spent, thousands of crores, is just nothing actually. If you can arouse the interest of youth.
But in continuation to Professor Rao, I am telling you, after the Mangalyaan mission, somehow I was invited to a lot of places to give a lecture on what is Mangalyaan, what he is going to do. And believe me, in West Bengal I face the maximum questions. Very elderly people. Whatever you say, Dr. Duari, 484 crore rupees spent on a mission called Mangalyaan by a country like India, which cannot feed 23% population 2 square meals a day, BPL. Was it necessary? To them I very sort of humbly said, according to Government of India, 13-14, the total cost, expenditure of fireworks in Kali Puja and Diwali was 5,000 crores. And nobody thought it's a wastage of money. And as we are Bengali, last year, in a published document, the total expense of Durga Puja was 21,000 crore rupees. Do you think it's a wastage or not? Right, that answers.
Good afternoon, sir. Thank you so much for your talk. It has made it worthwhile for all of us to come from so far away. I had two questions. First one is, I know that you talked about it, but could you please in detail explain the duration of a mission or when the timing is chosen for a launch, the month or the duration? Yeah. And the second one is, it's not related to Chandrayaan, it's related to Gaganyaan mission. Has the selection of astronauts started? Or are there any criteria for that? Or could you please just
Okay, I'll answer. Second one I'll answer as diplomatically as possible. Okay. Because originally you know that our target was to launch by last Independence Day or whatever it is. So selection has to happen. Okay, selection has to happen, but not exact, nowhere in the world for that matter. They know just a few days before only, among them also they know who is really going to, like between Neil Armstrong and what is his name? Yeah. Edwin Aldrin. Yeah. They were not knowing who will step on the moon till few days before also. So they will be there. But the process, yes, definitely must have happened. Okay. And the training, so because you would have seen a lot of things. Indian astronauts are trained in Russia, America, all those things you would have trained. So that means a panel at least, this one. Okay, that must have happened. If your objective in astronomy is you want to become one of them, okay, you can wait for next Gaganyaan mission. Okay, definitely you can apply and you can go there. So that is about that. And the first one, yeah. How do you select then of the launch date? First, if you have infinite resources, where you don't have constraints of fuel, which is not there for any country, for anybody, for Voyager and all, the launch was to happen on that day at that time. If it had delayed by few minutes, mission would not have been there like that. So that is because they are using within the available resource of the rocket's capability, you want to achieve certain mission of crossing so many things. Here in this case of Chandrayaan, it is to land on the moon. So for that, if you want to get the maximum optimization out of the fuel, like I told, once again I will tell, we want to land on the first day of the lunar day, first Earth day of the lunar day, so that 14 days of mission will be, observation will be there. Otherwise you spend so much and 1 week is lost because of the launch delay, then you have lost half the mission, no observation possibility. So that's why you want to reach on the first day. When you want to reach, and the second is you want to observe some portion of the moon. For that, the sun elevation angle, okay, so that is important. That has to be illuminated. That place has to be illuminated with sun at 25 degrees. Actually, I expected this question. Before coming, I discussed with the project director of Chandrayaan, you too, okay. When I was program director, he was reporting to me. That's why I sent him a message. I should not disturb you during these operations, but when you have 10 minutes time, please call me. So immediately the next day he called me and told, sir, for you what is there, we will tell any time. So I took this, so sun elevation angle is another aspect. Then accordingly they will try to back calculate. So if you are not having the limitations, maybe monthly 2 opportunities you will get. But because of the other limitations, we are getting yearly 2 opportunities. In each opportunity some 20 days, like that kind of window may be there. Within that, but every day, from today if you are going tomorrow, the launch time will change because you are a science student anyway. So the planetary positions are changing. So accordingly it is all.
Fantastic. Yeah, very nice way. Actually this, what is known as Hoffman transfer orbit. This is technical called Hoffman transfer. Here 2 things are seen. The vicinity of the object, like Mangaljaan. Earth at this point of its orbit, so that is also one of the factors that is taken into. And he is an ISRO person, he cannot say it, but he said I'll diplomatically answer. In the month of April, our long training has been finished by 4 IAF pilots who have returned to India. In addition to that, last year it started, ISRO has started its own human resource training program for astronauts.
Yes, so whole time I gave a lecture to the would-be astronauts. Okay.
Yeah, okay.
On the, because they have to be sure that their satellite will go up, no? So for that, what all we do for quality assurance, I gave a lecture to them. Okay.
Okay, so it was a fantastic. I know that. Please, there will be a lot of questions. By
The lunch session also
we can have a couple of 10 minutes, 15 minutes after this lecture when we can have a cup of tea or something. I don't know what is arranged. Lunch is arranged, so you can have a leisurely discussion of your questions. I sort of invite all of you for that. But first and foremost, I have to profusely thank Professor Rao. Profusely thank. It was a wonderful, wonderful session for all of us.
Sir, I think I was resisting, but now I have to make a correction. I am neither Dr. Rao nor Professor Rao.
Okay.
Just Mr. Prakasha Rao. And I want to add, sir, one more thing. I
Yeah.
just wanted to appreciate Madam
Yeah.
for her initial
Oh, yes.
introduction.
She
It was
is-
very nice, Madam. Thank you.
She's one of the giants
Yes.
of Bharatiya
And
Sanskrit.
शुद्ध हिंदी में जो वो बोले थे बहुत खुश हुआ मुझे. Yes.
And I also thank everybody today here, and especially I am very happy that very young, bright, scientific minds, mostly I can find out from ISRO, and also some professors from university and colleges, I know personally, they are here today. Thank you, all of you who have come. It was a wonderful success.
प्रकाश राव जी के लिए कि चमक गुणों से पैदा होती तुम्हें देख जाना हमने, बाहर से भी अधिक रोशनी भीतर है जाना हमने. मैं समझ ही नहीं पा रही थी कि आप ही हैं डॉक्टर प्रकाश राव. आए मेरे को दुआरी जी ने कहा कि यही है प्रकाश राव जी, और मैं तुरंत दौड़ के इनके पास गई कि अरे वाह, कितना कुछ एक इस अपने अंदर इन्होंने समा रखा है, और उसको कितने विनम्रता से हर बात का जवाब जिस तरह से वो दे रहे थे, वो बहुत बोस्ट करके भी दे सकते थे, हर बात को कितने प्यार से और कितने अच्छे से वो समझा रहे थे। हम सच में वो जो चंदा मामा वाली बात है, उस बात से विज्ञान और हमारा क्या संबंध है, हमारे जीवन में विज्ञान किस तरह रच बस गया है, इस बात को हम बहुत थोड़े रूप में जान पाए। इस तरह की कई मीटिंग्स होंगी तो हम शायद थोड़े और समझ पाए।
मैं I'm very thankful to Mr. Rao and my old friend. I met him in Hyderabad in a marriage by chance, and we developed a friendship. And ever since, whenever I have talked to him, I have found him very humble and very affectionate. Dr. Dwari, you know well, he is a wonderful person. Wonderful person. And Calcutta, Bharatiya Sanskriti Sansad and Calcutta is proud of having a person like him amongst us. Now, the main point is that Sansad is trying to have some talks on our technologies, on our science, our scientific achievements. See, whilst we are looking at our scriptures, we are looking in past, we are looking into something a different dimension. But we should not forget what is current, what is future. And what will be in future, that the best example of that is personified in Mr. Rao. Some people, the same question that why we are spending money on this. But after discovery of, after the contribution of NASA on many technical fields, lot of changes in our life has taken place. Lot of technologies have come into our life. I will not be able to name, I am not that proficient, but rather the society at large, government is spending so much of money, but society has to come forward to support our scientists, our technicians for this effort, and Bharatiya Sanskriti Sansad should always be one of the few institutions who are putting a humble flower at the feet of that Sanskriti Mandir, ISRO, and I certainly know that young people in Sansad will carry forward this, and we will have more and more such scientific discussions, and we are very, we are honored and very pleased to have young scientists, professors here, so wonderful. Now I would request all of you to take lunch, and I am very thankful to all of you, to Dr. Dwari and Mr. Rao, my friend.